Okay, can you hear me?
Yes, sir.
Yes, sir.
आज क्या कमी है? कितने 5 बचे हैं अभी? ओके, तो कितने आए हैं हमारे पास? 15 स्टूडेंट्स। ओके, सो लेट मी स्टार्ट शेयरिंग द स्क्रीन। आज मैंने ये नया ग्राफिक्स टैबलेट दिया है, देखता हूँ ये कैसे चलता है। तुम भी बताना मुझे, ये ज्यादा सही दिखता था कि पहले वाला? ओके, एक्चुअली हमारा वो डी पार्ट उसका रह गया था लास्ट टाइम, सो चलो उसको खत्म करते हैं पहले। ओह, 2 लोग और आ गए, दैट्स गुड। ओके ओके ओके, लेट मी सी। हमें एक्चुअली इसका डी पार्ट करना था, जरा मैं कलर बदलता हूँ। ओके, डी पार्ट ये था कि रेंज ऑफ टी, ये तो इससे स्मूथ है, range of T star is always a subset of kernel of P का annihilator, and I need to remind you that T is a bounded linear operator from T is a bounded linear operator from X to Y, and T belongs to Pxy, and T star का मतलब है adjoint of T, and T star is defined as T star at Y star is equal to Y star composition T. I should write here composition, मतलब एक ही है. So T star then belongs to, it's a bounded linear operator from Y star to X star. The duals. Okay. Now हमें दिखाना था ये कि range of T star is contained in the kernel of T का annihilator and equality holds. इसमें जरा equality नहीं जरा काम है. Equality holds if range of T is closed, is a closed set, and X and Y are Banach spaces, and they are complete. So this was our part D. हाँ, ये ज्यादा अच्छा है जो नया मैंने लाया. मैंने नहीं लाया, मेरे घर पे था. Okay, now proof. now पहले दिखाएंगे इसका सबसेट है जो कि rather easy है. Now let X star belong to the range of T star. It implies that there exists some Y star belonging to this capital Y star such that T star applied to Y star is equal to X star, because T star is a mapping from Y star to X star. अगर इसकी range में कोई होगा तो of course it would have a pre-image, of course. Now if X belongs to kernel of T, it would imply that X star at X जो कि बराबर है, but X star is actually T star at Y star applied to X, but T star Y star applied to X by the formula for adjoint should be actually Y star composed with T X applied to X, but that would be equal to Y star at 0 for all X belonging to kernel of T. क्योंकि अगर X kernel of T में है, then T of X would be 0. So this is Y star is a linear map, it would send 0 to 0. So which implies that it kills everything inside the annihilator. So therefore range of T star would be contained in the collection of annihilators of kernel of T. So therefore I can say that Y star belongs to, no sorry, galat hai, X star. x star belongs to the annihilators of the kernel. I had started with x star belongs to range of t, so therefore range of t star must be a subset of kernel of t, the annihilator. Okay, yeah, I have not. एक minute. Okay, now now we come to the equality. Now we are assuming that we have to show that this is equal. If RT, range of T, is a closed subset of Y, of course range of T कहाँ belong करेगी? Range of T is the same thing as Tx, right? Which is a subset of Y, a subspace of Y because T is linear. So we have to show that the reverse inclusion would be true if range of T is closed and X and Y are Banach spaces. यानी हमें उल्टा inclusion दिखाना होगा. So for that, now assume that range of T is closed and range of T is closed in Y, of course, and X and Y are Banach spaces. Okay. And let, अब हम इसका reverse inclusion दिखाना चाहते हैं, and let X star belong to the annihilators of kernel of T. Okay. So that is X star belongs to X star. इसका मतलब ये हुआ such that X star at X is equal to 0 for all X belonging to kernel of T. यही मतलब इसका एनालिटिक का. We have to show that, हमें क्या दिखाना है? We have to show that हमें ये दिखाना होगा अगर X star यहाँ है, it belongs in the range of T star, and we have to show that there exists some Y star belonging to Y star such that T star of Y star is equal to X star. This is अगर हमने दिखा दिया तो we are done. So what we do for that, we use Hahn-Banach theorem. I think Hahn-Banach theorem नहीं होगा, वो कहीं भी आ जाता है. So we define with the help of these X stars. G हम define करेंगे from range of T to K. So range of T से मुझे फंक्शनल मैंने क्या किया? मैं किया G of T of X, क्योंकि range of X में होंगे elements of the form T of X is equal to X star at X, where of course X star belongs to kernel of T का annihilator. तो मैंने इस तरह से मैप किया. So of course X star at X would be a scalar. So this is a map. Now, is it well defined? Of course, it would be well defined only if actually X star belongs to kernel of T first. Because if तो चलो if कैसे मैं लिखूं? चलो मैं ऐसे लिखता हूँ. If T of X1 is equal to T of X2 for some T of X1, T of X2 belonging to the range of T, it implies that चूंकि T linear है, X1 minus X2 is equal to 0, which would imply that X1 minus X2 belongs to the kernel of T. Now, which would imply that अगर X star belong करता है kernel of T, so it means that X star at X1 minus X2 अगर इसके annihilators में है, so we would get this is equal to 0, यानी X star at X1 is equal. Now, this step is true only if X star belongs to the annihilator of the kernel of T. And it is well defined here, which would imply that, of course, G of T of X1 is equal to G of T of X2, and hence I can say G is well defined over the range. तो मैं Tx का actually मुझे y लिखना चाहिए था, and of course G is linear because X star is linear and linear भी साथ में लिख देता हूँ मैं. Also T जो map है as a map from X to R, and T is of course by definition it is linear, and T belongs to bxy. Of course it is a linear and continuous map. और क्योंकि मैंने range पर ही लिया है map, it is on to map between Banach spaces. अब फिर से लिखता हूँ क्योंकि हमने ये assume किया है x and y are Banach spaces and range of T is closed. वही assume किया ना, बिल्कुल सही. Banach spaces यहाँ लिखेंगे हम x and y are Banach spaces and range of T is closed in y and hence is also complete, yeah, is a Banach space. Because closed subset of a complete metric space is also complete as a subset in the subspace क्या बोलते हैं, of topology. So this is a linear continuous and what we call onto a surjective map between open sets. So therefore, hence it's an open map. Hence it is an open map. Well, this is, तुम्हें याद है open mapping theorem? Anybody remembers open mapping theorem? सो गए? Hello dear, सो गए सब? Oh, सो गए? Anybody out of 24 awake? Open mapping theorem याद है?
No, sir.
Open mapping theorem याद नहीं है?
No, sir.
Okay. तो function analysis first में important theorem है open mapping theorem. किसी को भी याद नहीं open mapping theorem?
फिर शायद let G be a region and if it's from G to be analytic.
Sir, वो boundedness का.
Open mapping theorem मैं कह रहा हूँ. Open mapping theorem क्या कहता है? Open mapping ये बहुत ही fundamental theorem.
Sir, a surjective continuous linear map between Banach spaces is an open map. That is, it maps open sets onto open sets.
Very good. है ना? It is equivalent to another important theorem that's called closed graphs here. That a map is continuous if and only if it has a closed graph. So they are equivalent. And ये दोनों ही या एक ही theorem along with Han-Banach theorem are the two most important theorems in function analysis. So यहाँ पर हमने वही किया, we said that it's an open map. It sends open sets to open sets. So when I consider T from X to range of T, so then it becomes an open map. So there is a, चलो इसको हम यहीं prove करते हैं. चलो, so T is an open map. चलो मैं ऐसे लिखता हूँ. Actually मैं कोई theorem use करना चाहता हूँ, but I can also prove it here. लेकिन थोड़ा लंबा हो जाएगा, but within this ये आ जाएगा. So then T P1 of 0 is open in range of T. Right? Because this is an op by B10. चलो मैं लिख देता हूँ. It means all x belonging to x such that norm x is strictly less than 1. Open unit ball. तो अगर ये open है तो उसका मतलब क्या होगा? अगर ये range of T के अंदर है, then I can choose suitably, क्योंकि यही तो metric का फायदा है. P delta 0 का closure can be shown to be equal. I can find it inside P B10 because it's an open set. So I can choose a ball around 0 of some radius which is contained here. So I can make it further smaller and take the closure which lies inside this for some delta positive. So this is always true only because we can do this actually because there are numbers involved in metric and numbers can be made smaller and a radii can be made smaller to our liking. So let 0 और ये तुम्हें याद रखना है ये कहाँ है ये y में है. So let 0 a non-zero element, pick a non-zero element in y, then delta y divided by norm of y for any y would belong to b delta 0. And you have to remember what is this, you know? B delta 0 is basically the closure of the set. I could simply write it like this: y belonging to y because I'm inside a metric space. As so, this is what I have. So this belongs. Obviously, you just take the norm और देखो इसका less than equal to delta होगा because इसका 1 है. Okay. Actually equal to delta होगा तो इसमें belong करेगा. तो अगर इसमें belong करेगा, then there would exist x1 belonging to b1 of 0 such that t of x1 is equal to delta y divided by norm of y, है ना? Because this is contained in the range of t of b1 0. इसका मतलब यहाँ पे x है जहाँ ये मैप हो रहा है क्योंकि ये इसके अंदर है. It is in the range of b1 0. तो b1 0 में एक element होगा such that this is true, right? So let x be equal to, इसका उल्टा कर देते हैं, norm y into x1 divided by delta. This clearly belongs to x, right? Because x1 belongs to x, it's a vector space, हमने एक number से multiply किया. So that would imply then norm of tx जो होगा वो होगा, मैं क्या कर रहा हूँ गलत, मैं norm नहीं मुझे लगाना. तो थोड़ा सा manipulation using the fact that t is linear, I can say t of x is equal to 1. And more importantly, norm of x जो है वो बराबर है norm of y into norm of x1 divided by delta, which would be less than norm of y divided by delta. So that is norm of x is less than some gamma times norm of y, where y is equal, delta is some positive, gamma is some positive number, and y is equal to t of x. So अगर ये open map है तो पहले तो ये है कि surjective है, but it need not be one to one. तो वो तो हमारी actually assumption नहीं है, लेकिन अगर ये open map है, so I can find a pre-image such that it is in a way bounded below, है ना? It's like t of x यहाँ पे है, I can think of it as 1 by gamma into norm of x is less than equal to gamma times norm of tx, नहीं है ना? Usually हम लिखते हैं ना linear operator के लिए t of x is less than equal to some k times norm of x for some, this is true always. तो ये उल्टा वो जो inequality है ना, in a sense it is bounded below. और usually हम यहाँ पे tx इसलिए नहीं लिखते, बजाय इसके y लिखते हैं because it need not be one. So there could be more than one axis such that y is equal to t of x. But हम कह रहे हैं कम से कम एक होगा जो इस inequality को satisfy करेगा. थोड़ा सा calculation. Once we have done that, we are done. So मुझे ये मिल गया. There is some x. So let me, that is हमने ये prove किया. T is an open map. So therefore there exists a gamma positive such that for every y belonging in the range, there exists some x belonging to x such that एक तो ये कि इसकी pre-image है यानी t of x is equal to y and norm of x is less than equal to gamma times norm of y. Okay, so therefore जो मेरा g of y है जो मैंने define किया है to be g of y यानी g of tx और g of tx को जो मैंने define किया है that is basically x star at x where x star belongs to annihilator of capital of t और चूंकि bounded linear map है this is less than equal to x star into norm of x and using this so this is less than equal to gamma times norm of x star into norm of y. So इसका मतलब क्या है? It's a bounded linear operator. So therefore G is continuous. Oh, यार इसको फिर से करना होगा. Okay, G is continuous and therefore G belongs to, of course, y star. Not y star. हमने कहाँ से लिया था G? Range of T से. तो it should belong to range of T का star, which is a subspace of the codomain. So therefore by Hahn-Banach theorem, I can extend it to the whole of Y. By Hahn-Banach theorem, there exists, let me call it now, Y star belonging to the capital Y star because the range of T is a subspace of Y. Okay. Right. Such that it is an extension in Y star when the restricted range of T becomes the same as G. So once we have done that, then we are done. T star, Y star applied to X. Now this is by definition of the conjugate, it is Y star of T of X. But when Y star is restricted to the range, it becomes G of Tx. So then is by definition X star at X. Now this is true for all X belonging to X, which implies that T star at Y star is equal to X star. So that is, I can say Y star belongs to the range of, should I say like X star belongs to the range of T star. तो वही मैंने किया था, X star हमने शुरू किया था annihilator का kernel. So therefore कहाँ से शुरू किया था हमने X star? Therefore kernel of T star, the annihilator, is also contained in range of T star and hence equality holds. यानी range of T star, क्योंकि पहला वाला तो always true है, इसके लिए हमें चाहिए that range of T is closed. इसको हम use भी करेंगे I think आगे किसी theorem में. Okay, so we are done. ये उसका किसका B part था. So I leave it there. नहीं, ये हमने किया है. अब एक और है which is a sort of what should I say, something connected to, actually sort of a consequence of open mapping theory. Not exactly, but it is connected to that. तो हम ये कह रहे हैं कि अगर x and y are Banach spaces, let x, क्योंकि तुम्हें पता है open mapping theorem में Banach होना complete होना जरूरी. तो let x and y be Banach spaces. I wish we could discuss it in a classroom setting. Banach spaces and T belongs to, T is a bounded linear operator from X to Y. Then T is surjective. T is surjective if and only if T star is bounded below. बाउंडेड बिलो का आइडिया वही है जो मैंने इससे पहले किया था ना, यानी जब मैं कह रहा हूं टी स्टार इज बाउंडेड बिलो, तो मेरे कहने का मतलब ये है, बाउंडेड बिलो का मतलब नॉट इन द सेंस ऑफ बाउंडेड फंक्शंस, क्योंकि एक लीनियर मैप तो कभी बाउंडेड हो नहीं सकता. By that we mean this thing. There exists some beta positive such that beta into y star, beta into norm of y star is less than equal to t star y star in norm for all y star belonging to y star. There exists this beta positive. So इसका मतलब क्या है? इसका मतलब है अगर रेंज बाउंडेड है तो डोमेन बाउंडेड है, लेकिन ये चीज होती मतलब इट्स लाइक, सो मतलब इसका उल्टा जो होता है ना, बाउंडेड अबव इन दिस सेंस इज इक्विवेलेंट टू द कंटिन्यूटी ऑफ द, मतलब दिस इज ऑलवेज ट्रू, ये भी ट्रू है ना, ये तो बाउंडेड बिलो है, लेकिन ये हमेशा ट्रू है फॉर सम k times because t star is a bounded linear operator. ये तो हमेशा ट्रू होगा फॉर सम k पॉजिटिव, लेकिन बाउंडेड बिलो इन दिस सेंस, बिकॉज बाउंडेड बिलो तो होता नहीं, लीनियर मैप कैन नॉट बी बाउंडेड इन द सेंस ऑफ जैसे हम बाउंडेड कहते हैं दूसरी जगहों पे, यहाँ पे उसका मतलब है मतलब दिस जो हमने लिखी है इनइक्वालिटीज, तो दिस इज बाउंडेड बिलो, और इसको हम कहते हैं बाउंडेड लीनियर ऑपरेटर जब मैं ये वाला. ओके, सो पहला वाला तो इजी है, क्योंकि अगर T सर्जेक्टिव है तो वो ओपन मैप है. Suppose T is surjective, so therefore by open mapping theorem, therefore सीधे लिखते हैं T is an open map because it's a known theorem. It would set open sets to open sets. और जो हमने पिछले वाले में किया, then there is some gamma positive such that for every y belonging to y there exists, ये तो है ही, this is by subjectivity, लेकिन हम कह रहे हैं एक x ऐसा होगा which would have this property that norm of x is less than some gamma times norm of y. Okay, now let, तो फिर उससे वो हो जाएगा, let y star belong to y star. Now modulus of y star of y, क्या हो रहा है, because y is here equal to tx for some x because it is subjective. अगर ये वाला x हम लेंगे जिसके लिए true है, जो कि हम ले सकते हैं, so this can be written as y star of t of x for some x. So वो क्या होगा, that can be written as by the definition of the adjoint t star applied to y star at x conjugate, not adjoint. Conjugate is a little different thing. So this is a bounded linear operator, so this would be less than equal to norm of t star. फिर वो जो बनेगा वो होगा less than equal to norm of y star into norm of क्या बचा x. ओके, हम कहाँ आ गए, so y star at y is equal to this thing, so this is less than equal to, right, ठीक है, so which is less than gamma times, actually मैं इसको ऐसे ही रख सकता था, मतलब I don't need to break it, क्योंकि ये थोड़ा मेरे कहने का मतलब है मैं इनको इकट्ठे रख सकता हूँ, एक इनइक्वालिटी को बचा सकते हैं. This is less than equal to norm of t star at y star, लेकिन norm of x is less than gamma times norm of y, so it is gamma times norm of t star applied to y star into norm of x. ठीक है, मैं गलत किया, यहाँ y आना चाहिए.
Into norm of y.
बिल्कुल सही, into norm of y आना चाहिए. Somebody is
Yes, sir.
awake. So it would imply, so hence, तो चूंकि taking मतलब y तो यहाँ खत्म हो गया, कहाँ गया? You know, norm of y star is less than or equal to norm of y, so it is a bounded linear operator basically, है ना? यानी जब मैं कह रहा हूँ y star of something is less than or equal to k times something like into this thing. So what you take the supremum over the unit ball, taking the supremum over the unit ball, taking supremum over norm y equal to 1, we get norm of y star is less than or equal to gamma times norm of t star at y star for all of y star belonging to y star, or beta times norm of y star is less than or equal to norm of t star y star for all y star belonging to capital Y star, where beta is equal to 1 by gamma is a positive number. And hence हमारा एक side हो गया that t star is bounded below. Bounded below. Converse करते हैं. Conversely, थोड़ा सा converse इसका लंबा चौड़ा. Conversely, suppose that t star is bounded below. By bounded below, we mean जो मैंने पहले कहा था, there exists some beta positive such that norm of beta times norm of y star is less than or equal to norm of t star at y star for all y star belonging to y star. And you have to remember that t star is a mapping from y star to x star that is defined as t star at y star is nothing but y star composition t. Okay, so ये हम assume करते हैं. Now we first claim that इसमें थोड़ा सा time लगेगा. We first claim that for every y in the unit ball, for every y belonging to y with no y less than or equal to 1, there is some x. Actually, this is the ये जो मैं कर रहा हूँ ना, this is the essential spirit of both closed graph theorem and open mapping theorem. You know, there you can find an x belonging to the domain such that lies within a small distance or desirable distance of t of x, and if y minus tx is less than 1 by 2, ये जो मैं लिख रहा हूँ, whenever norm of x is less than or equal to 1 by beta, ये बीटा मैंने यहाँ से लिया क्योंकि मैं मान रहा हूँ कोई बीटा ऐसा एग्जिस्ट करता है. सो ये जो है ना, ये इसको तुम दिमाग में बिठा लो, ये इम्पोर्टेंट आइडिया है. यानी अगर हमारा जो रेंज है या रेंज का जो कोई हिस्सा है, या अगर मैं सपोज मैं कह रहा हूँ मैं यहाँ पे कोई ओपन मतलब बाउंडेड सेट लूंगा कोई यहाँ पे, so I can find a corresponding thing here such that it can be mapped within some distance here, within some small distance here. So that's the rather essence. ये जो आइडिया है ना क्लोज ग्राफ ओपन मैपिंग का, उसमें ये फंडामेंटल है. अगर तुम उसको ठीक से पढ़ोगे तो मेरे लगेगा कहीं ना कहीं पे ऐसा ही कुछ हो रहा है. ओके, नेक्स्ट पेज हम जाते हैं. तो हमें दिखाना है, क्या दिखाना है हमें? अरे मैं इसको लिखूं, यानी हमें दिखाना है, यानी फिर से यहाँ लिखना पड़ेगा y belongs to y अगर है within the unit distance of the origin, there exists some x belonging to x such that इसकी जो रेंज है ये y और tx के दरमियान जो डिस्टेंस है this is less than 1/2 whenever जो x जो है वो within certain distance of origin है. But here it is 1/beta. So assume to the contrary. अब ये लंबा चौड़ा हमारा आर्गुमेंट है और हमारे पास 1 मिनट वो मसला है. तो एक चीज मैं करता हूँ, मैं इसको अभी बंद कर देता हूँ, है ना, ताकि हम आराम से वो कर सकें, क्योंकि 1 मिनट के बाद फिर वो रिपीट करना पड़ता है. ठीक है, मैं इसको एंड करूंगा, तुम फिर से ज्वाइन करो. हेलो एवरीबॉडी लिसनिंग?
ओके सर.
ओके.